Welcome to the Spatial webcast. This is a recorded presentation and will be made available for future viewing on our website. You may go to www.petrosys.com.au and select the webinar or videos option from the drop-down list under support. Today's topic covers the display options in Petrosys mapping under the Display GIS menu. Although I will be using an Excel spreadsheet for the demonstration, the display options apply to all GIS sources. Also, today's presentation will be limited to using point data. Lines and polygon data will be covered in a future webcast. Many of the options used today will also apply to lines and polygons. In this presentation, I will show you the list of various data sources that can be accessed by the Display GIS option. Petrosys may add additional data sources in the future, so make sure you read the release notes sent with each new version. Release notes can be found by selecting Help from any window and scrolling down to the Release Notes section under Contents. I will also demonstrate how to set the symbols and symbol attributes for the displayed data. This includes default colors and sizes, as well as annotation of the symbols. I will show you how to filter the data to remove bad or unwanted entries. Using this option will allow you to keep data in the spreadsheet, which can be updated as new information becomes available. Much of the demonstration will cover the use of thematic mapping, which allows you to override the default colors and symbols. I will also show you how you can use available dip and azimuth information to post arrows or ellipses at the data points and label them. You can use three methods to display GIS data. The first is to use the menu item Display and select GIS from the list. A second method is to use the globe icon on your toolbar. If you have not enabled your icons, they can be set by using the menu item View and the option Toolbars and toggle on the Display Data toolbar. See the help pages for more information. The third method is to use drag and drop, which I will show you in the demonstration. When the Display GIS window comes up, you should select the data source of your elements. There is a drop-down list of the current sources, which includes Esri personal databases, various other databases, shapefiles, SDE, as well as text and Excel files. As Petrosys develops connections to other sources, they will be added to the list, and the release notes will inform you of the new features. After you have selected your data source, use the File folder or connection box to the right to pick the file or database. By default, the starting path for files will be your Petrosys project directory, but you can browse to any location on your file system to find your file. At this time, it is also recommended that you alter the default description string at the top of the window to describe your data, since this is a string that will be listed in the display list on the mapping window. This will aid you in finding the correct display layer if you have many items on your map. Now I'm going to go into a demonstration and show you these features. Here is a blank map sheet which I have created to display my data. I've already determined the coordinate range of the data. If you have been given a data set to display and you don't know the coordinate range, you can start with a dynamic map sheet, display the data, and then create the map sheet as desired. As I mentioned in the presentation, you can use the menu item Display to start, but I want to remind you of the drag and drop option for files that Petrosys automatically recognizes. In this case, I will use the File Manager option to open the project directory where I have placed my Excel file that I'm using today. If your file is located in another directory, you can navigate to that directory using the normal file system tools. The file I am using is an Excel file, so I will click on this file and drag it to the map sheet window and drop it there. As you can see, the data set is displayed as circles. The program has assumed that this file to be a collection of points. If these were contours or polygons, you would see a pattern. In a future webcast, we will show you how to adjust the file parameters to turn these points into lines or polygons. For now, we are satisfied that these really are points. However, I'm not satisfied with the display or the description of the layer in the display list. Notice that the description defaults to the data type, GIS, and to the file type, Excel, and the name of the file. To modify the display parameters, I can double-click on one of the circles or on the layer in the display list. Here are the default values the program has chosen for me. The important information is in the box to the right of the Define a Format button. When you click on that box, you're given the chance to modify how the data is collected. I will click on that box now. In this window, in the upper left corner, you will see a drop-down for Table. This allows you to select a worksheet other than the first one in the Excel file. In my case, I only have one worksheet. The next box on that row is used to switch from points to lines or polygons. We'll make use of this box in a future webcast. If your worksheet uses the first row to hold column names, there will be a 1 in the box for columns names online. And these values will be used to help you select the right column as needed. The last item on this line allows you to skip lines in the worksheet that may not have data. Just enter the line number where the data begins. In the left-hand window labeled Column Definition, you will see that the program has determined which columns contain strings, integers, decimal values, and coordinate information. In order to post data on a map, you must have easting, northings, or latitudes and longitudes. If the program does not automatically pick up your coordinates, you must use the drop-down in the Type column to set the columns for the correct type. The fields below that window will show you if the coordinates have been set or not. We're going to turn off the Has Z value checkbox, since that is used mainly for data extraction and other parts of the software, and I won't need them for the display option. The window to the right shows you a preview of the data from the file, and you can look for any issues. We will come back to this shortly. At the bottom of the window, you will see 3 buttons. Let's look at these in reverse order. The Validate Format button will bring up a summary window, which will show you the minimum and maximum values for coordinates and any selected Z values. Any errors are reported in the lower window. The Save Format button allows you to save this format mapping so that if you ever use this file again or an identically formatted file, you can reuse this on the previous page. The Save Format button will bring up a directory window where you can create a name for the file and choose what directory to place it in. The Load Format button similarly allows you to pick a save format for reuse. We are satisfied with this format, so I will click OK. Here's the Shape tab. By default, this tab is activated, which is indicated by the green dot on the tab and the checkbox on the display shape. Since this file has been identified as a point file, the line style and fill styles are not pickable. The point style is set to a black circle. I could click on this button and the window would pop up, allowing me to choose a symbol and its attributes such as color, size, and line thickness. There are several hundred symbols, and each company can add to this list. This option will use the same symbol set for all points. I want a proper symbol for each, so I will click OK to this window and use the option below. I will toggle on the Select Symbol via Attribute value and choose the PET-SYM column. At this point, I'm going to click OK and see if the correct symbol is displayed. And you can now see there are many other symbols on the screen. As you can see, the symbols have been changed based on the value in the column PET-SYM. Now I want to go one step further and color the symbol based on the current class of the well. Here's the column for the current class. As you can see, I have several classes for these points, showing oil, gas, etc. I can use the thematic mapping tab to assign colors and symbols based on the class. Let's go to that tab now. First, I will enable this option by clicking on the box at the top of the window. I want to set the symbols and colors for the shape, so I will toggle on Enable for Shape. Now in the window, I want to create expressions that will be used to select the proper symbol and color based on the current class. So I will use the Add button to build up my list. When I click on Add, I'm able to create an expression for each record. I would change attribute to current class, and then I must enter one of the values from that column. If I've forgotten what the values are, I can use the Scan button to bring up a list, and I can pick from the list. At this point, I should also update the label so that the label in the display list will match this class. I OK this window and return to pick the symbol and color from the attributes below the window. In case of gas, I will enable the point symbol and pick a gas symbol. And color it red for gas. I will then continue to use the Add button until I've chosen all my classes. Of course, I would not want to have to perform this matching every time I had a data set to work with. In this case, I've already defined all my classes and saved them to a style file. If I place my mouse within the window and right-click, I see an option to export to XML and import from XML. These XML files stores the definitions for me. I will now reload a file I've saved previously. Import from XML, pick my file, click OK. As I click on each feature, you can see the symbol number and color change below. I can click OK at this point and see the display update with the newly defined symbols. And here they are. Let's look at another possibility. As I bring up the display GIS parameter window, I can also see that I have a column named Symbol. This column may contain the symbol number used by a third-party application. I could use the thematic mapping tab to translate these symbols into Petrus's symbols exactly as I did for current class. Again, I could save the translation to my XML file and reuse it as needed. Keep in mind that you can import the XML file and add more records as your data expands and you pick up additional classes or symbols. This XML file can also be shared with others in your company so that each person does not have to go through the steps of figuring out the translations. Let's now look at the fields at the end of the records. This file has dip and azimuth information, probably related to the surface interpretation. We can use this information to make an informative map. First, we will change the symbol to an arrow, which we can use to show the azimuth direction. This is done on the Shape tab. I will click on the point style and select an arrow, which is symbol 27. I want to set the size to 20 so that we can see it on the screen. I could also change other attributes this time, but this is enough. I'll click OK. Back in this shape window, I want to control my symbols versus that column, so I will turn off the set symbol via attribute. While I'm posting the arrows, I also want to post the value of the dip. So I'll visit the Annotation tab. I find the variable dip and move to the right by highlighting it and using the blue right arrow key. At this time, I could choose other attributes, such as operator or well name, and post that also on the map. Each attribute can be posted independently from each other, or I could stack them up in one position. I will set the position of the dip to the right, and I'm going to change the text size to 10. Again, make it more visible on this map sheet. To the right of the Format Template, there's a Set button. If I click on the Set button, I will see that the number of decimal places defaults to 6. In this case, that's too much for my map, so I'm going to reduce that to 2. Notice there are many other options on this, including setting text that can be used as a prefix or a suffix. I can change leading zeros, use thousand separators, commas, and so on. We will now return to the Thematic Mapping tab. We look at the drop-down for Style, and we see other options, and there's one for Symbol Style. Notice these other options, Series, Exact Map, Series, Gradient, and Range Color, are other options that we can color our symbols based on other values. And these are covered in the help pages and also in our training classes. I'm going to choose Symbol Style here. When we select this, we see there are new options below. I'm going to use the Orientation tab, and I'm going to set the Rotation attribute to Azimuth. This is already defaulted for me. This will control the direction of the arrow. I can also go down to Length, and I can turn that on, and I'm going to set that attribute using the dip to determine the length. Now the arrows will be larger for larger dips, smaller for smaller dips. I know my dips range from 0 to 2.5, so I can use the custom scaling to make the arrows large enough to see. In this case, I am going to use a scaling factor of 20. That will make the largest one 50 millimeters long. So far, we've been posting all the data from the file onto this map. If I go back and view my data, I will see that I have some values here that look suspicious. They were keyed wrong or imported wrong. So I have a TVD of 100 where all the other values range somewhere in the 2,000 to 3,000 range. I want to eliminate this point from the display. I'll use the Filter tab to do this. So in here, I will apply the filter. And I'm going to choose the data column I'm going to be used to filter the data. In this case, I'm going to use the Zone Top TVD. And I want to eliminate any value that's less than 100, so I say filter everything is greater than 100. When I click OK, you will see that there was a value, a well up here in the top center, that is now gone. One last option I'd like to show you. We'll return to the thematic mapping and show you an example of the series styles. I'm going to show you series gradient, but the others are similar to this. This allows you to color the point symbols based on the data range of some column. I will use the Zone Top TWT attribute. I know that the values range from 500 and the bad value of 200. My data goes from 500 to 600, so I'm going to use a minimum value of 500 and a maximum value of 600. I'll use these values as the minimum maximums. I'm going to go with the Petrol's default color bar, red at the lower end, purple at the high end, and I click OK. You will see the symbols change in color. And remember, we covered the other examples in our training classes, and there are also help pages for the spatial data thematic mapping that you can use to guide you through using the other options. Okay, so this is the end of the demo. Let me go over and return to the PowerPoint slides, and we will wrap this up. Webcast demonstrated some of the display options available to you when you use Display GIS. This option allows you to post many sources of data without having to import the data or reformat it. You have great control over the symbol types, line styles, as well as color and size. Please remember that you can drag and drop your data onto a dynamic map sheet if you are unsure of the coordinate range of your data source. You can create a static map sheet once you have identified your data range. This is a quick way to quality control your data before moving the data to other sources. You have also seen that the thematic mapping option allows you to use embedded attributes in the data source to control your symbol, the colors, the annotation, and the orientation. Please contact Petrosys if you have any questions or comments or need more information. Visit our website to view other webinars and videos on various topics. Training schedules and dates of events that Petrosys attend are also listed on our web pages. Thank you for watching this webcast today.